Right. So again, a pleasant good afternoon. And those who may be joining in on the YouTube channel, maybe the Google Classroom, as well as if there's anybody else on the worldwide forum, because we do notice that the videos do get, 65 views on, some of them thousands if you leave them, of course, a couple of months, thousands of views. And so definitely we know it's not just Trinidadians or Guyanese, it's really the world looking at them. So just to mention, this is chapter 4 of the NEBOSH process safety management course. And this course is, of course, accredited in the UK. Certificate comes from the UK. It's globally recognized. It does have that status about it. It is examined though with a multiple choice exam, as I was saying before the recording. And you are not really required to get everything correct. Yeah, there are some NEBOSH courses like that. You have to get everything correct, like the NEBOSH project. But this is not that, right? This you have to get 24 questions correct out of your 40, and that will equate to 60 marks, right? As I was saying, if you just came in here, this may be our last full class. When I say full, I think full in that respect means like new knowledge. I know we're going to finish next week, and I know we're going to finish before the time. So again, next week, as I did with the environmental course, I told them that that we're probably gonna end up doing a past week, but next week anyway, and maybe the same for you all, right? So that's going to it. We do have some time, meaning that this today and next week is fine enough. The process safety exam may be the third Wednesday of August. That's when they normally do it. I have to get the confirmation from NEBOSH, of course, but that's when they normally do the exam anyway. Anyway, to get into the theory, so if anyone is looking at this, like I said, on the wider forum of the World Wide Web or YouTube itself, I have not really given the students 4 points of chapter 4. There was something psychological about that. What I did, I said that I would use the textbook then, right? So the course comes in a textbook that all my students would have. And to be fair, the book cost about 400 TT dollars, right? So to be fair, what I said we will do, we're going to use the book for chapter 4, right? So the most I could do here is sort of line up on the syllabus where we are at. We're on 4.2. And this is the syllabus I would have emailed this to all of our students. Yes, we can learn it on 4.2 and kind of follow through with that then, right? But really, we are not really following. I mean, we following the syllabus, right? Fine, we're following the syllabus, but we are really following the textbook. And I think it's probably one and the same. I say one and the same because actually NEBOSH wrote this book, right? So this is not a book from some bookstore that just happens to coincide with the syllabus. This is actually the book from NEBOSH itself, right? And as our students have the book, at least those of us in the class here in the region, we have decided to use the book. Oftentimes we find that when the book is not used, the students do not open it on their own then, right? So when I said there's something kind of psychological with it, it was that I was talking about, right? That so we use the book as a means of getting people to go into their textbooks. If they have never used it before, they're going to use it now anyway, right? And the most we could do is kind of line up on the syllabus where these things are at. So where we left it last week, we have already, let me just double check if I hit the record button. I actually know I did, right? Yeah. So we did look at the fire triangle last week. We did look at the three elements needed to start a fire: heat, oxygen, and fuel. We looked at conduction, the transfer of heat through solids, convection, the transfer of heat through liquids. And those of us in the book, you can find that smack on page 108. We looked at radiation, the transfer of heat over very long distances. And of course, based on the intensity of the heat, it could actually radiate as well. We looked at ignition sources and we left it on page 108 with well, basically every gas known to man has like an explosive range. Some of it was actually published in the book. We looked at propane, 2.5, the lower flammability limit, and 9.5, the upper flammability limit. And we had done a question asking where is the safe path, right? Like if you were in a company and they would have tested for a gas, we could stick to propane, but it has so much more on the table here. But the one we used last week was propane. Like, where is the safe range? And the answer that was given is going to be less than 2.5, right? Propane is 2.5. So where is the safe range? The safe range would be where like the concentration of the gas in the air is lower than the lower flammability limit, meaning that it's like the mixture of vapor and air is actually too weak then, right? It's too weak to support some sort of combustion anyway, right? So the safer range is around the 2.5. So those are the book. If you just look at the other page, you're gonna see the next thing here, which is a mechanism for and the possible consequences of jet fires, pool fires, BLEVEs, CVCEs, and UVCs. And yes, that is actually a heading in the book, right? So get your book out. Those of us who don't have it, well, you could probably, well, everybody have a book. We provide a book for everybody. If you don't have it with you, as is Sunday, we are not too sure if you're all on work or maybe elsewhere, right? And so you could just take the page down, and I will still do the explanation on the left-hand side here, right? So let's go straight into them. So what I'll do, yeah, we are going to use the book, right? But I'll explain them first, and we kind of touch them on the book, right? So as we go into this, what I'll tell you is that um, what you're looking at here, right? Like how the heading is a mechanism for and possible consequences of jet fires, pool fires, BLEVEs, CVCs, and UVCs. Um, not most of these are really types of fires. Most of these are types of fires. Some of them are type of explosion because if you look at, like a CVC is a confined vapor cloud explosion, the EDF explosion, right? And so let's see what types of fires these are. Now, when I said most of them are fires, it means that one of them is not a fire. But there's some of these here that are not fires. Kind of strange, right? Yeah, most of these are fires. You can see jet fire, pool fire, but these are not really fires. They are more like an explosion, right? Anyway, so a jet fire, let's go into that one. A jet fire is a fire that comes out at a very high pressure, a momentum, right? I think if you have seen, there was actually one on uh, Facebook here in Trinidad or TikTok where there's something at Atlantic LNG, which is a huge gas plant on the island that had a fire sort of propagating out of it. But the pressure that was coming out, I was telling someone that's a jet fire because the pressure of the fire then, right? The pressure of the flames, right, was pretty intense. So you could think of a jet fire like a line. And of course, we do have oil and gas in the region here, so like a pipeline. But it has gotten a leak then, right? If you want to think of this, God forbid, as an oil line or a diesel line, right? And this line would have been, of course, pumping diesel or pumping oil. But if there's a hole on it here, especially like a fine hole, like if you have a water hose and there's a fine hole on it, what you're gonna see, you're gonna see like a jet of fuel coming out of it then, right? It's like it's coming out at a certain pressure, it's jetting out, and hence the name jet fire. And of course, if this was really, to catch a fire, then the flame is gonna come out of it like that anyway, right? So if you wonder why we're focusing on that, because that's what the definition comes from a jet. A jet fire is a fire that has developed from some sort of leak and it is coming out at a considerable momentum or pressure. So you want to write that down because that's the catch there for exam, right? You can write down the word momentum. It'll take me some time to write it, of course, with the marker, right? But you can write it faster than me. And you want to write a jet fire is a fire that comes out at a considerable pressure. It's jetting out then, hence the name a jet fire, right? Writing with pressure here for you all as well. Remember, we all about explanation and we all about getting the exam as well passed. The exam is a multiple choice. So like it's supposed to be R, right? Pressure. It's kind of hard when you talk and you type at the same time. The human brain, I realized, could only do one. So URE, right? So this is fire coming out at a considerable momentum or pressure. So like I was saying, like for multiple choice, they will give you the four now or four from here because you have more than four here, right? And if they say, like there's a leaking gas line, pipeline, and the fire is coming out, they may try to hide up the answer then, right? They might say pressure, right? They may say maybe, and of course they wouldn't say jet either because if they say jet, it means they solve out the question, but they may say it's coming out at a high speed, right? And then what type of fire is that? And the answer is going to be a jet fire, right? Remember, multiple choice is not that tricky. And I've just actually told you how it comes. They really do come out more and more than that, right? Let's take a look at pool fire. So I'll do a couple of them and then we'll kind of read the book a bit, right? So a pool fire is sort of the opposite. So a pool fire is a fire that is going, so a fire has developed, but there's no momentum to it. Nothing is spraying out of anything there, right? So a pool fire, the best example for this is like a tank that has overflowed, God forbid, of course, like a tank that has overflowed, and the liquid is actually in the bond, right? So the collection pits, if you don't know it as a bond, I guess in the oil industry, they mightn't have a bond. Actually no, in the oil industry, they have a pit, right? They have a pit that would actually bleed into another pit, right? So there's a pit that goes into another pit. And this pit, if you're in the oil and gas industry, this pit may be off location at the end of the location. What's a location? A location is the area around the tank then, right? So you may have a tank there, collection pit, but then there's actually one at the end of that land then, right? If you want to think of it as a lot of land, 5,000 square feet, that final pit may be at the end of the land, and like in a corner somewhere. So there's a main pit. So a pool fire, there is really no pressure, right? Whatever would have fell here from the tank, maybe the technicians would have turned off those pipelines eventually, God, hopefully so anyway. And so whatever is here is like a pool. It has collected. And God forbid again, if there is some sort of ignition, bushfires are pretty common in Guyana and in Trinidad, right? And so it's a pool fire. Now, there's a technical thing here, and I don't know if you have to know the technical thing, but I'll say it anyway. So what they say though is really not the liquid that is the pool. But I don't think that will affect the answer, because if they say, which is a pool fire, right? And they give any example, a pipeline that has developed a leak, um, I don't know how to give you four answers on this spot, right? But what they're looking for is like a tank that has overflowed. And technically, what they say, for those of us who know, it's not really the liquid, but it's the vapors of the liquid there. Remember, for anything to burn, including something solid, like if you had to burn this, you had to heat this up. If you have a lighter and you're heating this, so when this cardboard, right, folder gets enough heat, it will start to vaporize, right? And the vapor is going to mix with air, and that is what they say creates a fire, right? So in a way, technically speaking here, I think the best way to think of it as is really a pool, but the technical content is not really the pool that's burning, but it's really the mixture of vapor and air that may actually be like a fog. If you all have seen some of that, like a vapor cloud, and that's where it's coming to. So that layer of mist then, M-I-S-T, may be in the form of a circle, which is why they call it a pool fire, right? So the technical thing here is not really the liquid, but it's a mix of the vapor and air that is in a sort of circle or pool floating above the liquid level, and that is what causes the fire. And in a way, that's kind of correct, because, like I said, to burn anything, you have to heat it up where enough smoke or vapor, we say smoke, but it's vapor that mixes with the air, and if it reaches the right concentration, that is what is burnt. Anyway, I don't think that piece is important for exam. The thing about the pool fire is that it's associated with tanks and bonds or collection pits, if you want to write that down. And it's associated with the fact that it's low pressure. There's really no pressure, as opposed to the jet fire. A pool fire is known by the fact that the liquid level is just there, and the vapor and air mixture is just there, floating above the liquid level, right? So there's very low pressure associated with a pool fire, right? So if you get it, we're going to check the book out now. This word here, sorry, I had to admit somebody, but this is supposed to be low pressure. I will check the book out and see if we can get these two, out of the way anyway, right? There are questions on them, but I've just told you exactly how the question comes. Jet fire associated with like a hole in a pipeline, And the pool fire really associated with some sort of spill in which the vapor and air have mixed and the vapor and air has formed a pool. But they would say something like low pressure, so you know it's pool fires, right? Let's take a look at the book, right? Let's go to jet fires. I'm reading straight from the book, so you can listen up a bit, right? This is on page 109. You can just let me know if you have the same page. What happened? I pulled an old version of the book. The reason is that, but this is actually my book, right? The tutor book here. This is since 2017. Is it page 109 for you as well? If not, it'll be page 108 or 106. But this is the book I
109
okay,
page.
109. Yeah, so this is a book I have home now. I'm home and at the office I normally find the new copies. Like what you got as you paid for the course this year, we ordered a batch of books. But it seems to be the same page, so very good. I thought I had a new copy home, but I don't, right? Exactly. Exactly. I'm not on the Bosch course. Incident investigation, right? Yes, yeah. I actually don't live in my textbooks. I know some people probably think, like, wait, this man has been sleeping in the books. No, it's just that I'm at the work table now, so all the books are right here. Anyway, jet fires, right? So jet fires occur when a spray of fuel is released rapidly as a steam under pressure from a process and ignited immediately on release. This results in a jet of flames being released with some considerable momentum. Notice those are the words we have on this slide, right? From one or more point in the process. Right, let's go to pool fires. So you see jet fires, high temperature, high pressure, everything high there because it's a jet fire, right? Pool fires, page 109, but on the right-hand side. Pool fires result from the spillage of fuel, liquid condensate under low pressure, which are ignited after release and the pool has developed. There may also be they may also be the result of a tank or pipe failure that has not ignited as a jet fire, but has traveled out of the container to form a pool before being ignited. Now, what they're talking about traveling out of the container is the vapor, right? So like if you've been to like a party, like they have like a fog machine, even if you have the spillage in the bond, the vapor could come out and the vapor is just like a mist, right? And if there's a wind, the vapor could actually move away from that liquid level. And if somebody is smoking, or there's some ignition source, a vehicle backfire, something, it's going to ignite. And if it is flammable or highly flammable, that's going to run back. It's going to run back to the pool itself, to where the liquid level is, and ignite that as well, right? So you see, they mentioned it, the term running pool fire, right? If a pool fire is not restricted to a single location, example, by being held in a bond, the liquid release may travel to another location, igniting on the way. Such fires are called running pool fires. In other words, the pool is not fixing a location, but moving. There is no real momentum, though, in a pool fire, unlike the jet fire, and the pool fire can occur whether the spillage is on a solid surface or floating on water, right? We could go on. A pool fire may also be involved with the ignition of vapor at the top of a storage tank, a so-called rim fire, which results from the failure of the rim seal or spill over of the tank contents into the roof as a result of overpressure. When a pool fire is burning, not all the vapors may be consumed, and some may be blown away to form a vapor cloud and may ignite and explode, right? So we cannot touch on all of that. You can turn the page a bit, those of us in the book, and I'll take off my two diagrams there. We're going to go on to here what we'll have to do. We'll have to do CVCEs first, and then UVCEs. I wonder. And I then think we have to do BLEVE. I think that's the principle of them. When I say principle, it's like how they occur, right? I'm taking off this, right? So let's go to CVCEs. And so this is very simple. There's no need to spend too long on this, right? So CVCEs, it stands for confined vapor cloud explosion. And again, that word is self-explanatory, right? Confined vapor cloud explosion. So these types of explosion occurs where the source of it then is confined, right? So you may want to think about like This could be like an underground storage tank, right? I'll draw one here for you, an underground storage tank. The source of it is confined. This could even be like, like a sort of a subway system, wherever you have your fuel level. You can think about the gas station, right? The Guyana Oil, the Shell, the NP we have in Trinidad. There's so many different gas stations in Guyana. But the thing is, the thing was confined then, right? So again, perhaps there is some sort of leak. This could come just on the heels of a pool fire, right? So this is underground, but there's some sort of leak. If this is gasoline here, there's going to be a vapor cloud, right? That is created there. And if there is some means, if this is some manhole, there must be like a testing port there. They make a testing port where the technicians will put, the fuel levels down into the tank here. That's us drawing this line here, right? And if there's some sort of leak, then you're going to have a vapor cloud. And again, if that vapor cloud does become, ignited, it's going to result in a confined vapor cloud explosion, right? So this is a man-made one. Well, I mean, most of these may be man-made, but you do have like, I guess, maybe caves and stuff that you may have gases in them, like methane. A lot of these though are really, man-made things anyway, right? So a confined vapor cloud is that the source of the fuel then is confined. You can think about like a subway system. You can think about, I guess, in this case, an underground gasoline tank, right? A confined vapor cloud explosion. And the other one is an unconfined vapor cloud explosion. This again is just on the heels of the one we just said in terms of the pool fire, right? So unconfined or UVCEs happens a lot, or the most common examples of them is like a tank overflowing. Again, we had just looked at this in the pool fire, where a tank may have overflowed. Yes, there may be a collection pit, and that may have led into another collection pit. But the vapor doesn't have to stay there. The vapor could come and travel all the way out of that compound and get into some trees, which is what happened in this story. Yeah, this actually happened in a place called Bunsfield, right? And it met an ignition source, and then because it's vapor and the atmosphere is sort of flammable, the fire is going to run all the way back and get all the way back here. And in the case of Bunsfield, burn the entire plant to the ground. There should be a picture of that in your book, I think. If not, well, that's the story of this. That's the story of the unconfined vapor cloud explosion. Let's check it in the book a bit and see page 110. It's that simple, right? It's that simple. Okay, let's check the book, page 110. So when a release of volatile flammable hydrocarbons occur, it is possible that if there is sufficient quantity and the environmental conditions are right, that the vapor will form as a cloud. When the cloud reaches an ignition source, the vapor air mixture may ignite. There will either be, I guess, a flash fire or an explosion, a vapor cloud explosion, depending on how quickly the flame propagates through the cloud. When this occurs in a confined area, the explosion is called a confined vapor cloud explosion, right? So it was that simple. All right, unconfined vapor cloud explosion. So when the vapor cloud forms in an unconfined space, as what we have drawn here, like the vapor, the fog, if you want to call it that, the vapor left the bond, it left the collection pit then, right? Generally outdoors, the formation and spread of the cloud depends on atmospheric conditions such as wind speed. Such clouds may form from large loss of contents of the vessel if it's gasoline, storage tanks, or pipelines. If the cloud comes in contact with an ignition source, it may flash, ignite, or even explode, right? The loss of containment at Bunsfield is an example of this as an explosion. And Bunsfield, there's a link on page 110 for you to look at a video there. If you have some time, you can go and look at it. I would describe it for you. Bunsfield was a aviation storage bonded for Gatwick Airport and Heathrow Airport in the UK, right? So it's where you had aviation fuel being stored, and that spill occurred and the entire facility burned to the ground. No one was killed though. So that's the good thing about Bunsfield. No, like nobody died in Bunsfield, right? But the tanks, I mean, if fuel tanks are burning, you have to kind of let them burn. But the fire services and the like even the independent contractors and stuff they had associated with that Bunsfield station, they were able to use a foam. If you look that up on YouTube a bit, you were able to use like foam and powder, and they were able to bring it down within like about 2 to 3 days anyway, right? And so the good news is that nobody died in Bunsfield, right? Let me take that off. See if you have any question. In short, a confined vapor cloud explosion is where the vapor have mixed with the air, but it's coming from a confined source, like an underground tank. So they call it a confined vapor cloud explosion. UVC is unconfined vapor cloud explosion. A spill has occurred, like in a pool fire, but then the vapor cloud would have left the bond and traveled away from the bond. If it meets an ignition source, and if it's something like gasoline, it will still ignite the richness of the vapor, like where that trail is coming from. Then that fire is going to run back to the source, if it's the bond itself, if it's the tanks, and again, cause an explosion, right? Because it was unconfined, as it is in a bond, the name given to it is an unconfined vapor cloud explosion, right? So these are common, right? But the most common one is the BLEVE, right? So let's have a look at the BLEVE. I'll have to take these off. BLEVE is in your book, page 110, right? Let's take these off. So the BLEVE, in a way, is not, some people say it's not really a type of fire. So that's why I said that when you look at them, some of these are really types of fires, like jet fires, pool fires. But some people say a BLEVE is not really a type of fire. But what it is like a phenomenon that creates the fire. Kind of strange, right? I'll explain in a bit, right? So a BLEVE is like the mechanism by which you can have a CVCE, and a BLEVE is the mechanism by which you can have a UVCE. In other words, and the BLEVE really describe the characteristics of what is happening. So BLEVE, if you have your book, is actually short. Of course, it's an acronym, right? I mean, all of these, well, we said in jet fire and pool fire, but BLEVEs are short for boiling, page 110, boiling, liquid, page 110, if you're watching it, right? Expanding, vapor, or vapor cloud, explosion. So if you look at it, it really telling you what happened. Boiling liquid, expanded vapor, cloud, explosion. So that's what it is with BLEVE, is really what's happening to create a CVCE. Could be. Well, BLEVE could be, well, a BLEVE mightn't happen for a UVC, right? But BLEVE by itself at the higher levels, and in the book, as we said it, I'll show it in the book just now, the BLEVE itself is really a characteristic of how an explosion could occur. The liquid have to boil, the vapor have to expand. And if it meets a source of ignition, you're going to have an explosion. So in a way, BLEVE is more describing what is happening other than the type of fire. Anyway, let's take a look at it, right? So a good example of this, I guess, is your propane tank, but I wouldn't probably use that. I would just use a tank, right? So a vessel, right? So if there is a vessel, a tank, you can think of your propane tank, of course, right? And this is, propane, of course, is a good example. Propane, when it's in the tank, it's in the liquid form, and you turn on the nozzles in the gaseous form, right? But for like a tank or a bigger sort of industrial vessel, um, probably shouldn't put that there. Anyway, probably put this is just the top of the tank, right? That's not really the hole. That's just the top of the tank, right? So there may be some sort of relief valve here. Most tanks would have that on them. So a relief valve, right? And what they say, again, we're just going to assume that if there is a fire, right? If there is a fire, what they say, the liquid in the tank is going to start to boil. Hence, it's boiling liquid, right? So the liquid in the tank starts to boil. I'll draw some bubbles there for that, right? And that's because the tank is on fire. This marker is really difficult. We can think of it as bubbles, of course, right? So the liquid in the tank starts to boil. So the pressure is going to increase. Now, when the pressure increases, the relief valve is open. Now, in the process industry, this relief valve may just carry the contents to another tank. It mightn't vent into the atmosphere then, right? I just saying in the process industry, this may just go to another vessel. right? Some sort of neutralizing chamber that will actually neutralize this increase in temperature here. But even this one may have a vent. So let's say the vent does vent. So the liquid starts to boil. Think of water you're boiling at home then, right? And if by some chance you have ever forgotten the fact that the pot was on the stove, right? Well, by the time you come back, the water level will get low. So if it was rice you were boiling or whatever, right? Or, you were making chicken curry or curry chicken, right? And you didn't watch it too well, you sort of burn the curry, right? And so the thing is, what's happening is almost the same thing that as this thing starts to boil, the vapor then, if whether or not you neutralize it and it's eventually released to the atmosphere, the liquid level is actually going to go down. Let me just grab my marker again, right? Because as it's boiling, it's like steam there, right? So the liquid level is going to go down and go down and go down, right? Let me try to, I don't think I could clean it because if you go to clean it, it just erase the whole diagram, right? So eventually what they say is that the flames are going to be acting on the metal of the tank itself because the liquid level has gone down. The liquid would have been taking some of the heat there. And when the flames are on the metal of the tank itself, it may cause the tank to burst, right? Now that does result in a huge explosion because remember, this is like a flammable substance inside here, right? And that is what they say a BLEVE is. In short, a tank is on fire, the liquid level starts to boil, the pressure may be relieved in some extent, the liquid levels will drop. When the liquid level drops so low, like you have something on the oven at home, or not the oven, sorry, the stove, and the source burn out then, right? The flame is going to be on the metal of the tank. That may cause the tank metal to weaken and to burst. When that happens, it results in an explosion, and that is going to consume the whole vessel anyway. In fact, with huge portions of this tank becoming a projectile. Let's have a look at your book. You'll see it right in your book, right? Page 110, but way on top, it starts way to the top, right? I'm trying to drop off some lines though, but does start way to the top. I'm trying to see where they say the fire starts, right? Okay, so page 110, the first paragraph, left-hand side. And I guess I read from the top, right? Many gases, such as liquefied petroleum gas, LPG, are stored at high pressure in tanks, like your propane tank. This enables the gas to be compressed, so it forms a liquid and so takes up less space than it would do if stored as a gas. This is extremely useful, but it can also be very hazardous. If the storage vessel fails in the same way, if a tank containing such a liquid is heated up, again, I mean, not to say I want to think about it, but it happens for your propane tank as well as at home, right? Example, by the involvement in a fire, the heat transfers to the contents, despite the insulation designed to protect the tank, and the contents boil. Example, turn to gas. Eventually, as the liquid vaporizes, the pressure in the tank increases to such a point that if you do have a pressure relief valve, it would operate and release the pressure to the atmosphere. Hopefully not, and hopefully into some sort of blow down drum, right? But release the pressure to the atmosphere, usually as tanks are open or stored in open air. The valve then closes, but the heating continues. At some point, the development of pressure in the tank will be greater than the pressure release can cope with. And where the flames of the fire is impinging directly on the metal of the tank, the heating of the tank weakens its structural integrity until the increase in pressure in the tank from vapor expansion causes the tank, sorry, to rupture. At that point, the pressure is released instantly, and there's a very high volume of rapidly expanding vapor and high energy explosion results. This phenomenon is called a boiling liquid expanding vapor explosion, or BLEVE. It is essentially a mechanical event because huge portions of that tank now will be tossed around. And there are many examples, even though they are not covered in this course. Remember, there's a degree level to this. There's actually one in Mexico City. I don't think they mentioned that here. But there's actually one in a resort in Mexico where a gasoline truck, well, truck then, right? Tanker, um, had some mechanical failure and the truck, as we say, shut down next to a resort in Mexico. And as luck would have it, a fire developed. I don't know if somebody was smoking or whatever have you, and that happened, right? So the tank heated up, relief valve operated, and what is it? The vapor cloud from that, like the mist, traveled to where it had tourists in a hotel, like a five-star hotel, right? And it met a source of ignition, exploded. The fire went straight back. Of course, it's gasoline. Gasoline is called gasoline because it's gas. Some people don't know that, right? Just the obvious. Gasoline is called gasoline because it's a mixture of gas and liquid. And anyway, huge portions of the tanker went into the resort and killed people who were relaxing, sunbathing, right? So yeah, these things have happened before. Other than that, for exam, they like BLEVE, right? And how they bring it actually have a question in your book. How they bring it, they will just describe it for you. Like how I read it there, they will say like a tank is on fire, the liquid level starts to boil, the pressure relief valves open, the excess pressure is vented into the atmosphere, maybe a vapor cloud develops, they will talk about that. But they will say the liquid level drops and then the metal of the tank is exposed and the tank ruptures resulted in huge portions of the tank being sent in as a projectile. What best describes this type of fire? A, levee, B, CVCEs, C, UVCEs, D, pool fires. The answer is going to be levees. And that's done. Right? Tell me if you have any questions. 4.1 is finished. 4.2 will go a little faster in 4.2. I said we may just leave out one thing today, which is 4.4. Right? See if you have any questions on this one. So we covered all the types of, well, not all, I mean, but all in the syllabus really, right? We have covered jet fires, pool fires, CVCs, UVCs, and the phenomenon that is a BLEVE. I think that's the right way to say it, right? The phenomenon that is a BLEVE. What do you all think? Alive, sleeping, waking? Anybody out of the 14 persons on the live?
We are live. We are live.
You're live, you're live. Okay, good. These are feedback. Yeah, okay, good. All right. Let's go to again. If you have your book, this is 4.2, same heading, fire and explosion control. I'll try not to overdo it though, but I'm still trying to explain where have a question. Like I know that's a question. We all know BLEVE is a question, right? But it don't have to be BLEVE. It could just be one of these. It could just be jet fires or pool fire. But one of this comment out of the 40 question, one of that comment, right? All right. Here what I'll do, right? Again, I'll stick to the idea of explaining, and then we'll kind of touch back the book a bit, right? So fire and explosion control. If you look at the book, what they actually do, they mention a lot of detection systems on page 111, page 111. They mention a lot of detections, like, when I say detections, like a smoke detector, what your book and you'll see. They mentioned smoke detectors, heat detectors, gas detectors, right? So yeah, I mean, I think that's a way of detecting a leak. You can use, some sort of detector if it's a smoke detector or a heat detector or a gas detector. I don't think there's anything more to it than that then, right? Like for exam. I mean, I think there is more to it, but it's not more to it than for exam, right? So a heat detector will actually detect changes in the temperature actually in the room. So there are many types of heat detectors, and I don't know if this course going to all of that, right? So there are many types of heat detectors, right? There are some that will pick up a change in temperature in the room, but that's not the best one, right? The best one is I see it. It's in the book and I didn't mention the name, but They didn't mention it like if it's a type, they just mentioned like a line, right? So one of the best types of heat detectors is something called the rate of rise heat detector. I don't think this is common for exam, the rate of rise. I just telling you that they have many types of heat detectors. So the rate of rise doesn't have like a fixed temperature there, like a fixed temperature detector. But the rate of rise talks about like the temperature would have changed suddenly then, and then the detector will go off, right? So if in the Caribbean and South America, I mean, our days are really hot. Um, I was looking at somebody in the UK last night, and she was saying the temperature is so hot. And when I think she showed the temperature was like 20 degrees Celsius. But that's kind of hot for England because, I'm in London, for those of us who know, and even I guess Canada, right? Certain parts of the world, the average outside temperature is 17, 16, 17, 18, 19. Hot days, they call it 20, 21. Heat wave, if they get 22, they call it a heat wave. This is true, right? Check it out for yourself and see. I think London, if you have your phone, you can Google the temperature in London. I think is about I don't know it today, but I didn't check it today. But I heard somebody say 14 degrees it was last night. But you can Google it. And the point I'm trying to say is like, like the Caribbean, we have and South America, we have hot temperatures. When I was across there, I remember telling the kind of like what the person who was helping me with my bags now, but it wasn't like a bellboy. I'm not too sure what they would have called him, right? But I was telling him our temperature is like 34. And this man couldn't believe this guy was like, what? What are you saying? How could the temperature be 33, 34 on a normal day? I was like, yeah. He couldn't believe it. And my mother did never experience it. If you are accustomed to temperature of 16, 17, 18, how the hell temperature can be 34 and people live in? And so what I'm saying with a rate of rise is not about how hot the place is now, it's about how fast the temperature changes. So if the room temperature is 33 or 30 or 31 and it changes quickly, that detector will pick it up. So if it was up somebody being 31, but we know the temperature could go to 34, but then that may take the duration of the morning then or the evening time in the Caribbean, right? So from maybe 12 o'clock, 1 o'clock, 2 o'clock, 3 o'clock, the hottest sun anyway, right? So that heat detector would not go off because that's just a normal increase in temperature. But the rate of rise is if there's a sudden increase, then it meant something must have done that. There must have been a fire. Something is in the room to create this rapid increase in temperature because naturally it could go up to 34, but it has gone up to 34 or 40 in such a short space of time. That's called a rate of rise heat detector. Folks, I should not have mentioned this because it's not exam. I don't know what make me talk about this, but I don't think there's a passive on that. Sometimes in the effort to cover content, we kind of explain too much sometimes anyway, right? So let me just go to something that I think have a question in it. So if you look at page 111, there's something called active fire precautions there, active fire protection and passive fire protection. That tends to come for exam, active and passive. Let me just explain it and we'll touch it in the book. Listen to it, right? So in the effort to control a fire, we have what I call active controls or active protection and passive protection. So to make life simple for you, active is anything that human beings sort of have a role in that. Like if you're using a fire extinguisher, that's active protection. If you watch here, right? So include manual. Active fire protection system include manual. So somebody's using an extinguisher and automatic operation features. Like if you have a sprinkler system, pay attention to it, right? A sprinkler system may still be classed as active, right? A suppressant system, if you want, you can make some notes here. A suppressant system is still classed as active, right? So anything that and that's automated, but like they use the word here, automatic. I mean, you should think automatic is passive, but automatic doesn't mean passive. Automatic is still is active. Like a sprinkler system, then you may not have to be there to put it on. I mean, if there's an increase in temperature, the alarm will go off. If the alarm is linked to the sprinkler system, then the water will start to come down, or the foam, or the mist. If you use CO2 or the powder will come down. But that's still active. But if that's active, well, then what is passive? right? So I'll say this again. Active is anything that includes, and you should probably learn this because remember this as an exam. Anything that involves human beings and some of them being automatic too, like an automatic sprinkler system, an automatic dilute system, still is classed as active, right? Well, so the question asks that if that's active, then what is passive? What characterizes something to be passive? And passive really talks about, if you turn the page, you'll see it, page 112. Passive have to do with materials that have been treated, like to withstand fire, like your Numex, right? Like like paint, certain types of paint have heat insulating properties. Like if you paint the building or you use a fire door, they mention a fire door in the book. A fire door is a door that has been designed to withstand fire. They call that passive. So passive refers to things like paints, coating. I don't know if you all know any, it have some, they sell them in the hardwares, I guess all over Trinidad and Guyana. There's something called gypsum mud. Anything that you can put a coating on, like you can paint with some sort of, fire resistant paint, they refer to that as passive, right? If you look at the book, they say passive includes things like preform boards, cladding, this is page 112, wall lining. These are usually made from fire resistant materials, glass, mineral, or ceramic fibers, right? If you look down, you'll see spray coatings, seals, and sealants, right? So those come under the category of passive. Tell me if you get it right in your book. Yes, anything to do with the sprinkler system, you'll see that's under the heading of active. The sprinkler system is under the heading of active. And so this could be a nice multiple choice question. They can say which of the following is a active form of, in fact, they may ask passive, which of the following is a passive form of fire protection. They have a worker using an extinguisher, sprinkler system that automatically trips, but automatic is active, right? Then they will have, like uh, a wall that has been painted with, uh, but I hope they're not, I don't know if they will sell it, but some sort of seal or sealer, they may just say seals or sealer. And the fourth one may be something like some sort of dilute system, right? So if you say which of the following is passive, it's going to be seal and sealants. So you need to learn this, right? There really is no other way. I don't think there's another way, right? The book has some really nice examples. I don't want to go outside of that anyway. I also cannot remember any other weird question. I could just remember that sort of question, like which of the following is passive, which of the following is active, and you're more going for passive, things like cladding, sealants, paints, those kind of things is what you're going for. There isn't any other confusing question here, right? The only thing is that they may switch it around and they say which is active now, and then they give you sealants, paints, wall cladding, and then they will have somebody using an extinguisher. Well, active would be the one that's using the extinguisher. Nothing else is confusing here. Tell me if you're okay, that's done. So we're on to page 113. And we did page 113 already, but I want to re-emphasize it because I know it's a question. And 4.2 is almost finished. Like I said, I think we may just be at the last couple of points in 4.4 when it gets to 230 today. Right? Let's go to anybody have any questions? Let me know. So with page 113, we did this already. This is the hazardous area zoning. Well, you all should remember this. I could ask some questions. But this is two questions here. Well, hopefully, right? I mean, I know you're gonna get one, but some passive buzzers ask twice, right? So remember, there is a law for this. If you check your book, there's a couple of European, directives and stuff. Page 113. You don't really know, like the exact directive EC 9992 EC. You don't have to know that for multiple choice, but you all did a question like this, right? So there's a hazardous area zoning, you have 0, 1, and 2, and then you have 20, 21, and 22. So your question to me is, or your question for me is, which of this is gas and which of this is dust? Which zone is meant for gases, which zone is meant for dust? What numbers are meant for gases and what numbers are meant for dust? Anybody?
1 and 2 for gas, and
Very
20
good.
for
Yeah.
dust.
Okay, so this is gas up here, and the other one down there is dust, right? And you also saw a question on this, those who were here. What they will do, they will describe an area and they will tell you to zone it. Or they will probably zone it and just you describe it, something like that, right? But like the one we saw on the past paper, it didn't book another paper, still in the book another question in your textbook. We could turn to it if you want, but I ain't want to as yet. But if you were not here, it's on page 127. If you were not here, if you missed that class and you didn't get a chance to look at the video, you can go to page 127. The question is there. But this is just one question. And I might have the makeup questions all the time, right? Like the most recent one I think I told you, I saw one with somebody in a gas station. They asked to zone where the operator was, where the pump attendant was, right? Now, they didn't give the option of zero then. It had four answers. It had 1, 2, I guess it had 21, 22, right? So the access zone where the pump attendant was, right? Now the best answer would be 1 because that's meant for gas. This would all be wrong because it wasn't dust we're talking about, right? It was gas. And 1 means the pump attendant is an area that is likely to be, he's likely to be exposed to, like a flammable gas then or gas in the atmosphere. So the best answer was zone 1, right? But to me, if they had given 0 as the answer, 0 would have been the best answer. But they didn't give 0. They just give you 1, 2, and 2 other numbers, right? Let's take a look at this one, page 127. Please learn. Like you all have no reason to fail, eh? You see, if I was just teaching and not telling you the question coming, you could fail. But here we stop and we telling you, look, hey, learn the zones or learn active and passive, right? I did mention to you all we'll finish next week. That'll give you like maybe 2 weeks or a week and a half to study. The exam, I think, is the third Wednesday in August, right? So strap up your book. If you all see mine, I can show you my book. My teachers, right? Well, remember I brought this course to Trinidad. I was telling the class this morning that I know it sounds like kind of redundant, but the environmental course, I brought that to Trinidad in 2014, right? And we were the first to bring, I don't think anybody doing process. Look at the condition on my book, right? So that proves to you that I just use it. Right? Anyway, I was telling you another story. I was telling you, like, when I was studying, remember, it didn't have these courses now because we who bring this course, back then I was a student, right? But as the owner, then I brought these courses to Trinidad. I brought the environmental in 2014. I brought the process in 2017. But when I was studying, I remember one of my teachers came around and the tutors were lecturers now. It really was lecturers. And she was like, what is wrong with your book? And my book was such a mess, right? My book was mark up and scrap up and you know what I tell her? I mean, it's tertiary education, so I can't tell nobody. Plus, I was big and I was working and studying, right? But I told her it don't really matter how it looked there, no? It matter how it look up here. The fact that it looked like that in physical meant that I getting it here. And that's what I'm trying to say, folks. Strap up your books this next 2 weeks. Well, it's the last of July. Strap up your books and carry it with you. It don't matter if something fall on it. It don't matter if some chicken curry fall on it or curry chicken. Right? The thing is you want to pass. This is your book. The book we give away is all your book. We're not coming back for it. Don't feel we're coming back for it. That book is yours. Right? So feel free to I used to carry mine to work. Remember, I told her I work in but not this book. Please remember it's another course I'm talking about, like my first degree then, right? Like I used to be sleeping at like lunchtime. I would try to do 2 things on a lunchtime. Number 1, eat, well, maybe 3 things. Take a quick nap and get up and study. Yeah, I was working on studying, right? So I tell you, strap up your book and wherever I was at, if it was on a pipeline, I carried my book, right? Lunchtime I eat and I take out my book and I study and it didn't matter how it looked physically, it mattered the fact the information was here. Remember, you have an exam to pass. I cannot pass you as much as I like you. I cannot pass you, right? So I don't care how your book look. Make sure you get the information in your head. Strap up your book and start going with it, right? Start studying it. wherever you could. I find very creative places to study. Like if I'm in a bank, like if I know I go in the bank, again, folks, this is not now because remember these courses were not around then. But if I was going in the bank, I carried my book. You see how it have a long line? I carried my book. Yeah, it have a long line. I start reading. By the time I read out a chapter, it's my turn to go up on the line, right? When I had my, well, I have my sons, but when I was waiting to pick them up in school, right? I would go with my book. You have to reach there before school over because, parents and traffic, right? While I waiting for them, I read in my book, right? And so, you have to find creative ways, especially if you're working, folks. I know what I'm talking about. Remember, I work whole day today, Sunday, you're here, I here, right? How is it that a working person can make out, right? You had to find creative ways. Well, you all have creative ways. Like back in my day, we never had videos. You all have these videos on YouTube on top of that. So while you're driving, you could listen to a video. And I say listen to man sleep away, but you know, you can play music. When you wake up, of course if you're sleepy, play very loud music. That's what I do. But if like it's a brighter part of the morning, put on the video. You're going to work, is an hour traffic. To hell with that. If it's traffic, well, let it be traffic. Yeah, I mean, you can't do nothing with that, but put on the video and listen to it. Find creative ways as an adult or as a working adult to study. It wouldn't be forever. Folks, it's just a couple of weeks again, but your NEBO cert is forever. Your NEBO cert is forever. It doesn't go away. Once you get it for life, right? And I fed up tell you all stories. I don't want to tell any more stories at the moment, right? But as a working person, people find creative ways to study. Don't just say, I'm not getting time, I'm not getting time. Find creative ways. Find creative ways to carry. It don't matter if you bend your book back. It don't matter if your book in a mess. Find creative ways to study. Because you have to study, right? I'm moving on. Anyway, zones. So please learn your zones because again, you're getting a question in it. So if the teacher tell you a question, come in. How could you not study it? How could you second guess yourself? If you study them numbers 0, 1, and 2, 20, 21, 22, when you see the question in the paper, you go smile, you go laugh. You go say, ah boy, I catch them. I was waiting for this question. I'm waiting for this question, right? And what about all the others? What about the management system? What about the PDCA cycle, right? What about BLEVE? You're waiting for the question, right? I'll end this little pep talk with one little thing, right? Like for me, when I was studying, I couldn't wait for the exam. That was me. I couldn't wait. Now, if you wonder why I couldn't wait, because you see, for me, I felt as if the exam was keeping me back. Like, would you all be here today if I didn't have a master's degree? Would you all be here today if I wasn't qualified? No. I felt as if, but when I was studying and I felt as if like this thing keeping me back, man, I had to get this out anyway. Right, Quincy? I had to get this out anyway. I have like I want the exam to come because I want to move on with my life. The exam keeping me back, right? That's how I saw things, right? And I say to you all the same thing. I mean, you all are all young or young at heart in some sense, right? Don't let your academics keep you back. Get it out of the way. Get this thing for life. I wish I had this back in my day. I was studying the class this morning. Do you know that I am the only one that cannot do this course? Because I have the license, right? My name is on the license, so I cannot do this course. But I would have loved to have process safety. I would have loved to have NEBOSH environmental. I who bring them here, so I cannot do it. It's like a conflict of interest then, right? But you all could do it, right? I was studying the class this morning. Maybe if I retire in the years to come, I'll probably do them. But then what would be the use of them to me? I guess it would be nice as a working person then, right? For now, I am the only one that can't hold process safety certificate, but I can hold a license. So in a way, it's a kind of give and take, you know, fair. I don't have it personally, but I have it as the company name now. But I don't have it personally, but you all can have it and you have it for life, right? Folks are moving on. Hopefully that pep talk help you out a bit and you can get your books going this week here. All right. On page 114, I'll just mention them here. They talk about the ways of preventing an explosion. So let me just mention them and talk about the past paper, right? So the ways of preventing an explosion, they have atmospheric control, pressure relief devices, which would vent the contents of the atmosphere. automatic explosion suppression systems, automatic isolation, maybe I'll explain that one for you, and they have flame arresters, maybe I'll explain that one for you, right? Let me just explain them and I'll tell you the question. So atmospheric control is that you use nitrogen to purge the atmosphere. Now, if you use nitrogen, it means you take out the oxygen. Why is that good? Is because oxygen, remember, is needed for combustion. The fire triangle, right? Heat, oxygen, and fuel. So atmospheric control is very good, as a form of explosion control. Let's just jot down the automatic isolation. So if you don't know what this one is, automatic isolation is like if you have a valve. So there is a valve, right? You could actually turn that valve and it can isolate then whatever the source of the liquid or the gas was at, right? So I've drawn the valve there with it screwed on then, right? So that's automatic isolation. So if this was, like lower down this line here, had a fire, right? Should draw the same size. Yeah. So if lower down they had a fire, right? So it could cut off the fuel source, then automatic isolation. That's what it's called, isolation, right? It could be automatic, it could be manual. It could have an operator that turns the valve, but in process safety, there's something called a ROSALV, remote operated shut off valve, ROSALV. But it don't have to be automatic. It could be a manual person that comes with a wrench or something, or even your hand, and you turn that valve head and you turn it down. That's automatic isolation. Well, that's isolation, but in the sense here, it's meant to be automatic. So then it's meant to be remote operated shut off valve, or ROSALV for short, right? Flame arresters, let me tell you what that one is. So if you do have a flame arrestor in your line, I'll tell you what it is, right? So a flame arrestor in some sort of gas line, and this is a good control, right? Is like a catalyst. I don't know if you ever heard that word before. You may have heard it. Well, you all kind of I mean, I know we have some young people here like Kamini and, you know, perhaps, let me see who again, perhaps Daniel. But those of us who had older cars, uh, there used to be something in the car called a catalyst, right? Especially the cars from Japan. And most mechanics would actually advise you to take out the catalyst, right? Because it will cause like a reduction in your fuel to your engine and stuff, right? What the catalyst is, it's like a Jack Spanier nest, right? Is something that looks very small, but it have a lot of small holes inside of it, right? And that's like what the flame arresters is. So the idea here with these flame arresters is that if there's a fire here in this line, these holes, I have drawn them big, but it's very microscopic, right? If the holes are so small that the fire is not able to be sustained there. Like a fire need heat, oxygen, and fuel. So because the holes are so small, it's going to cut off the oxygen. And once the fire reaches the flame arrestor will be so small for the fire to go through, then and it can't go through, it can't sustain the oxygen content, and it will die down, right? So that's called a flame arrestor, right? Anyway, beside the explanation, let's talk about the pacifier. Listen to the pacifier, right? Listen to the pacifier. Here what they ask, right? They ask which is the best one. They ask which is the most effective in explosion protection. Which is the best one? Just try to make a guess. Out of these here, we could take the first four. 1, 2, 3, 4, because the correct answer inside here. Let's take the first four. We taking this one, we taking this one, we taking this one. Flame arrestor is not the best, because remember, a fire have to start for a flame arrestor to even work. So flame arresters are not, when I say they're not good, it's not the best then, because it's not proactive. A flame arrestor means you have a fire in your vessel, right? But that's something you don't want. You don't want a fire inside here. So flame arresters would never be the best solution, right? But if they ask you which is the most effective in terms of explosion control, is it atmospheric control? Is it pressure relief? Is it automatic explosion suppression? Is it automatic isolation? Make a guess. The answer in them four right there. Should I bring some water in your mother? Since morning I talking to you now, so I had another class. And I realize, anybody, quick, make a guess. I mean, this is not the exam. I given you the answer. Let's make a guess. What do you think is the best one to prevent a fire?
Is it atmospheric control?
Yes, it is atmospheric control, right? So the answer is always going to be the first one. You see, if you purge with nitrogen or whatever you purge with in the first place, right? It didn't have any oxygen. So then you don't need a pressure relief system. You don't need an automatic suppressor. You can have it as a backup, as a reactive control. But the one that is highly proactive here is the first one, atmospheric control. Let's take a read of that one in your book now. That's the question. Yes, if you have your book, run your highlighter. Don't be afraid, I'll tell you. Years to come, if when you pass the course and you'll be telling your kids, those of us who don't have kids as yet, you'll be telling them still, you passed NIBOSH and this is where we in the UK, right? And this is the book you use. You'll be like me, telling a story, right? Atmospheric control, right? So here they have, here, the atmosphere is managed through the introduction of an inert gas such as nitrogen or carbon dioxide in order to exclude oxygen and prevent the formation of a flammable mixture. But I don't think, like I said, I mean, because it's multiple choice, you're not really getting to describe. Like you're not getting to describe, it's not, like drawn label, but it's multiple choice. So which is the best one? It's always going to be atmospheric control, right? Folks, take a look at page 115. I'm just going to mention this briefly. They mentioned that tanks and other storage vessels should have a means of preventing sources of ignition, for example, from lightning strikes. If you don't have your book, I'll kind of show you that picture there. And they have a lightning rod that must be connected to the earth, and then we can make that out there. So then in case of a lightning strike on a tank, yes, remember tanks from last week too, if this is an aviation fuel tank, let's say you're storing oil, you're storing gas, right? You don't want a lightning to hit your tank and, ignite everything. So the tank normally has like a lightning rod connected to the earth. Again, those of us who know a bit about electricity, you know why? Lightning and any form of electricity is electrons. Electrons are attracted to the earth because the earth is positively charged. Right? I just thought about something interesting here. That's why I smiled. But I don't know if here is the place to talk about it. I'll tell you about it still though. As you turn the page to dust, so I have realized, I don't know if anybody have realized too, there's a lot of literature out there and videos on YouTube and stuff on how to relax now. Today is Sunday, like how to relax, right? And I am not a believer in total relaxation. Like I cannot totally relax. When I say that, like, I don't think, and no offense to the ladies here. So I can talk from the perspective of of a male, but as like a breadwinner, and I know many of you all are the same thing, Alim, and like as somebody with responsibilities, and like I cannot totally relax unless like things are in place then, like you can't, like as a man, then you can't totally relax knowing that, like you want a better job or, so there is relaxation. I do that all the time and you all know that. I went to the park this morning, but there's always something that you're looking to do that, right? Anyway, so why I mentioned this for is that I have been realizing a lot of people are saying like a way to relax is to put your feet on the ground, on the earth. And at first I thought it was stupidness, right? I thought it was like how we say stupidness, but it does make some sense, right? Because they say when people rub off on you, you actually do pick up electrons. But electrons is only attracted to the earth. Electrons are only neutralized if you're in contact with the earth. So if your feet is in shoes whole day, of course, some religions, if you put this in a religious perspective, they tell you to take off your shoes before you go and pray and whatever have you. So there's a lot of truth to it. I just say, right, like right now I'm barefoot. Sometimes if you come to the office, have you ever come to the office and notice that I'm in a slipper? I have a big Nike shoes pack up there, but my foot is in a slipper, right? So it's just maybe something you can try if you're out for a walk or whatever. Just take out your shoes a bit and put your feet on the ground. There's a science behind it. You do pick up electrons, you do pick up energy then, right? And vibes or whatever you want to call it. And the only way it's going to get rid of is if electrons is attracted to the earth. So why not just put your foot on the ground? I actually saw a company, Amazon, actually selling earth mats. What the hell is an earth mat? It actually have people who can't put their foot on the ground. You can't really put your foot on the ground. So they sell them like a mat, but it's a positive mat. When I say positive, it's positively charged then. So whatever electrons, whatever vibe you pick up in the day, you can put your, that's a nice invention, right? Like if you can't touch the ground, I mean, people, I guess, in developed cities, maybe London or whatever, New York or whatever, if you can't put your foot on the actual earth, you put your foot on an earth mat. Strange things, right? But anyway, it's all about Sunday. It's all about recharging and getting ready for, the week ahead anyway. All right. Anyway, that's what I'll tell you. No, I do have another master's degree. I don't know if I ever tell you that. I have a master's in health, and it's health and safety, but I actually have a master's degree in health as well, not just safety. I don't talk about it too much, but you can pick up from what I just tell you the other night. I actually have some more things that it's not just safety then. Actually, the term is called health and safety, but a lot of companies, there's no focus on health. There's actually a focus on safety, but health, without health, you can't have safety. If you're not medically fit, then you can't have safety anyway, right? And of course, fitness here talks about both physical and mental anyway. Anyway, the point of this, get some relaxation on. After class today, I'm actually going to the mall, right? So anyway, dust explosion, right? So why dust explosions occur? Page 116. Now page 116 is going to go into page 117. So what you're looking at there is something called the dust pentagon, right? And the dust pentagon reflects the 5 things needed for a dust explosion to occur. Now, if you watch it carefully, if you want to watch it carefully, please, I'll show you. You want to watch it carefully. What you'll notice is that it have the same 3 elements of fire. If you have your book, you can watch yours. If not, I'll write it on the slide just now, right? So a dust explosion occurs whenever you have these 5 elements in the correct size, quantity, and proportion that mixes with the air. And if you look at it carefully, you would see, well, if you stick to the fire triangle, you'll see a source of ignition, which is heat. You'll see a source of oxygen. You're going to see a source of fuel. However, there's 2 things needed for a dust explosion again, which is a source of confinement and a source of dispersal. And let me explain, right? So maybe I could give an example here, right? So what has happened in the past, like a lot of companies, like in the flour industry, right? They would have, and not just flour, cereal or whatever is in product making, right? So this represents a conveyor, right? So like a conveyor, if you want to call it a rolling conveyor, whatever you want to call it, right? So this may have flour on it, flour. Should I probably draw some more? So flour or grain or cereal or whatever have you, right? So a lot of companies, because of contamination, they are now putting a guard around their conveyor. In other words, then they're covering it up, right? So if you look at it, you wouldn't see, but what you'll see is like a guard. The whole thing is in a house in that, right? So the conveyor is housed now in a covering, right? So you're not seeing, well, I draw it in that way we can see through it, right? But remember this to be solid, right? So the conveyor is now confined. The conveyor, because of, cause of concern for contamination and biological hazards and cleanliness and tidiness and stuff, a lot of companies, I mean, this is like on the talk of every manufacturing company. They call it contamination control. It's big on contamination control, right? Because you don't want, somebody, if it's the feed industry, the chicken industry, you don't want somebody to get some sort of, stomach bug, some sort of illness, and then it's traced back to your factory, right? So there's a huge emphasis on contamination control. Anyway, what's that all about? Well, what that does, it creates a source of confinement, right? So the conveyor itself is a source of heat, oxygen, and whatever you had there, if it's cereal, grain, or fiber, whatever, right? That's a source of fuel, right? Now, because you have covered it because of the cause and concern for contamination, you have confined it, right? And what they say, if you look at your book, well, you're starting to create then the conditions needed for a dust explosion. if there's a right particle size, right? If there's an ignition source inside here, what is going to result? Keep looking at your book a bit. What is going to result here is what is called a primary explosion. If you look at the syllabus, you'll see it too. Look at right here. Primary explosion. So in the conveyor itself will lead to a primary explosion. Now check this. When the primary explosion occurs, it tosses the dust then, all what was inside. I have just drawn a cross section. This is a cross section, right? This is not the length of the conveyor in any means. This is like a cross section that we kind of looking at then, right? So the rest of it is still going there, how long that factory is, how much convolution it have. So when that occurs, it causes the dust now or whatever you had, flour, powder, milk, right? Cereal, whatever, right? Oats. I did a factory with oats if you heard me mention that story before. I'm not going to mention it again, right? Right in Trinidad here, in Trinidad, right? So whatever it is now, because of the primary explosion, the dust from that, whatever you want to call dust, milk, powder, cereal, whatever, right? It's tossed in the atmosphere. And now, because there was a fire here, these things heat up. That's the source of dispersal. See if you're seeing that in the dust pentagon. You need a source of confinement. But a primary explosion leads it to like dispersing the dust in the atmosphere that already has a fire. And if that's in the right concentration and proportion, it's going to result in a larger secondary explosion. Right? So right here, I have a question right here. We don't have to go far. It have two questions right here. It have three questions right here. First of all, you have to learn the dust pentagon. Heat, oxygen, fuel, confinement, dispersal. I'll show you a question just now. So we almost finished. It's 20 past 2 early, right? Heat, oxygen, fuel, confinement, dispersal. I explained the confinement. It must be something that they did, or maybe it's a subway system, maybe it's something underground. There's some kind of confinement happening, and then there's a primary explosion, right? The primary explosion is going to toss everything up in the air, in the atmosphere, that may become ignited as well, resulting in a larger secondary explosion. Let's go to the book to see that. And I'll come back to the two other pacifiers, right? Remember, I said I have three. The first one is knowing the elements of the dust pentagon. All right, so page 117. As we have seen, the condition needed for dust explosions to occur are fairly prescribed. What do you mean by that? They mean the five things you must have, right? It is unusual for such conditions, example, explosive concentration of dust to be present in the general atmosphere, as these would at a basic level need to be controlled for operator exposure and health issues. So that's why these things will happen just like that. It have to be confined, like they confine the conveyor for contamination control purposes now, right? As a result, most dust explosion happens within process or equipment where conditions for the explosion can be achieved more readily. These explosions are known as primary explosions. The primary explosion can be quite minor in itself, page 117, but it does disturb within the building, on the floor, grinders, line on the vessel, etc., then forms an explosive mixture and is ignited, causing one or more secondary explosions that can be devastating, right? I just spotted two questions, right? Housekeeping and dust control is therefore essential in any area where processed dust are generated, right? So let's get to the other two questions. Other than the five things, heat, oxygen, fuel, confinement, dispersal, the next thing is that they could ask you, which type of fires have a primary and a secondary explosion? Now, watch how much fires we talked about today. Jet fire, pool fire, BLEVEs. But which one have a primary and secondary? It will be dust explosion, right? The other famous question I've seen, I think I'll show you that one because we almost kind of running out of time. I'll show you in the book, right? Or they on this, but not this slide. They would say like, what's the best way to deal with like a fire then, a dust explosion? Once the primary explosion has occurred. That may not be the way to say it. So I probably should rephrase that. But I already don't know the question. I just kind of improvising, right? But like, what's a way to prevent a secondary explosion? Anybody could think of it? What's a way to prevent an explosion? Should a primary explosion occur? What's the best way to prevent a secondary explosion? The answer is in the book and the answer is on the little note right here. You'd be shocked to see what the answer is. It's a very simple answer. What's the best way to prevent? Like if this was to happen then, right? And let's just keep it at the primary explosion level. Let's not let it get to the secondary. So if something happened in the conveyor and the conveyor catch a fire, we could take an extinguisher and extinguish it. How do we then prevent the secondary explosion? What's a way of preventing a secondary explosion? The answer is good housekeeping. Look at right here. Right? You see, if you have good housekeeping, how the book mentioned, listen to what the book said, right? The primary explosion can be quite minor in itself, which is good. We could deal with that. But it does disturb within the building. Page 117. Example on the floor. Well, if it's on the floor, we could have dealt with it. We could have had proper housekeeping. But it does disturb within the building. Example on the floor. Grinders and line on the vessels. Well, what's it doing line on the vessel? We should be keep the vessel clean. Right? So you could have a primary explosion and then you could deal with it right there. The primary explosion itself could just be extinguished. But you want to prevent stuff from building up then. If you've worked in a machine shop, if you've worked in some factories, a lot of stuff, well, a lot of the factories are kind of clean now. Uh, Talking about a lot of them that service, when I say service, let me rephrase that provide things to like price mart or like larger distribution centers. What I've realized, price mart would actually visit those factories and make sure that they're clean. This I know from experience, because I've been in part of one. Price mart would actually tell a factory what to do and how to do it. And if you don't do it, well, they're not taking goods from you. Right in Trinidad, they're right in Chaguanas, right? And as an example of one factory, Nutramix too, if you all know Nutramix in Trinidad, very, 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 very tidy, state of the art, right? So a lot of factories are kind of catching on to the housekeeping bit that if they have proper housekeeping, they could probably prevent, I guess normal safety accidents, hazards, slip, trips, and fall, but they could prevent things like, from escalating then what would have been like a normal fire anyway, right? Folks, let's try to find a question. We'll have to stop here for today. I don't think I'll run it down. But 4.3 is finished there now. The only thing you'd have again, if you I don't know if you want to do it because we have 5 minutes, it's just how to prevent dust explosion. Let them right here, right? Explosion relief venting, explosion suppression or containment, making sure your plant are sited away from populated areas and have proper construction for your plant, proper concrete walls and whatever have you. You'll find them on page 118. If you look at page 118, something's supposed to catch your mind. The best way to prevent dust explosion is what? Where's the first one? Page 118. Good housekeeping, right? Avoidance of ignition sources, explosion relief venting, explosion suppression and containment, plant siting and construction. What that means, don't put your plant close to a populated area. Read it and you'll see. Have proper constructed bricks and stone. I'm watching the book and I'm telling you, right? Page 118, right? And 4.3 is finished. Leaving just 4.4, but I had suspected to you all to finish next week, Sunday. We'll finish this in about maybe 45 minutes time for the max. And what we can do next week is actually do out an entire past paper. Right? Let me try to find a question here for you all in terms of, I wonder if there's one here. Let me see if there's anything. The page 127 have some questions in it. Yeah, question 5, page 128. And if we could probably do number 6 too. We could do all of them on page 128 if you want. We have 3 minutes, but let me start with the main one on dust. And if we have a couple extra minutes, we can do number 4 and number 6 as well, right? Page 128 have some questions. But notice what I say, the emphasis is on housekeeping. And I didn't really say that. The book said that when it turned to prevention, The first thing they had was good housekeeping, right? All right, question 5, it says, in processes that involve combustible dust, why is it especially important to maintain good housekeeping? A, dust can build up on a variety of flat and irregular surfaces, which can spontaneously ignite. I don't think it can spontaneously ignite, but let's read the rest, right? Dust on surfaces can be disturbed by primary explosion, causing a larger secondary explosion. That sounds kind of like what I was trying to describe. So maybe B, but let's see C. Dust build up on surfaces can be clearly seen by visitors and give a poor image of the company. Also true. However, that's not what we are talking about. We're talking about dust explosion, right? Not the reputation of the company. D, dust will adversely affect limit sensors and proximity switches, causing them to malfunction. Maybe, but still that's not what we're talking about, right? So the best answer is which one? The best answer is B. Okay, let's try number 6. We have 1 minute to go. 1 minute to go, right? Flammable liquid leak from a storage vessel onto the bond which surrounds it or surrounded it. The liquid began to fill the bond. They say flammable liquid, I just keep that in mind, right? Liquid also began to leak through the cracks in the bond, which is the walls of the concrete catchment, right? And flow towards a faulty electrical pump, usually used to empty the bond of rainwater. Within minutes, the entire bond was on fire, taking several hours to extinguish. What is the best description of this type of fire? And if you don't know, you can just take off the wrong ones, right? A, jet fire, B, pool fire, C, flash fire, D, secondary fire. Well, A is wrong because this is not under any pressure. B could be correct. The book never mentions C, so that's wrong. There's no such thing really as a secondary fire. There's a secondary explosion. So by deduction, I have mentioned here when I wrote it on the slide, bonfires, B-U-N-D, and not B-U-N-D. B-U-N-D, bond fires from like spilled liquids is normally associated with a pool fire. Says how easy exam could be, but you have to study. You're seeing that? Exam could be easy, but you have to study. Exam could be hard too. You could say, wait, now I remember doing that or not, but I can't remember it now. Well, why did you waste all this money? Why did we pay Nibosh all of this money then? Right? So try to get the words of what you pay for. Exam could be very easy, but you prepare. I've told you my stories, and I'm going to tell them again. You prepare, start preparing, right? Prepare. So when that week come, you're ready. You're ready for them, as they would say. Can't wait for the day of the exam, right, folks? I'll have to stop here. We should have finished before though. This is our 8th session. But again, like I said, sometimes the past papers do, or the past paper reference is what takes longer